Hello, Lexi students, Miss Marsh here. Today you're going to want to have your notebook out, the handouts I gave you, and then also a pencil. You may need a calculator as well. Today we're going to do graphing function rules. Your learning goal: I can make a graph that represents a function using tables. So basically what you're going to get is I'm going to give you a function of some form, or a function of some form, and I'm going to ask you to make a graph for me. So I have this function y equals negative 2x plus 1, and you're going to need to make a graph. Now, we are going to always use these following x's for when we make a graph of our function rules. We're going to use a couple of negatives, so negative 2, negative 1. We're going to use 0, and then we're going to use two positives, so negative 2, negative 1, 0, 1, and 2. That's the common numbers that you're always going to want to use because they're easiest to plug in. Now, let's plug in negative 2 for x and see what we get for y. So I'm going to put negative 2 times negative 2, because that's my x, plus 1. So that is 4 plus 1, right? Because negative 2 times negative 2 is positive 4. Plus 1, that's 5. So my answer is 5 for my y. So my ordered pair would be negative 2, positive 5. Let's continue on. Got to plug in a negative 1, it says. So let's plug in a negative 1. So I'll get 2 plus 1, which is 3, right? So my y is 3. I will have the ordered pair of negative 1, 3. Because remember, your ordered pairs are always x and y, because x comes before y in the alphabet, right? Good way to remember it. I know y equals negative 2 times 0 plus 1, because I'm plugging in 0 for x. So negative 2 times 0 is 0, plus 1, that is 1. So my ordered pair is 0, 1. Let's try the plugging in the 1. So I'll get negative 2 times 1 plus 1, so that's negative 2, right? Negative 2 times 1 is negative 2, plus 1 is negative 1. So my ordered pair is 1, negative 1. Now let's plug in 2. So y equals negative 2 times 2 plus 1. Negative 2 times 2 is negative 4, plus 1 is negative 3. So my ordered pair is 2, negative 3. Now, I have filled in my entire table, all 5 points. What you're going to now need to do is graph this function. So let's graph these ordered pairs. Remember, graph x, then y. So negative 2, I'm going to go over 2 to the left and up 5. 1, 2, 3, 4, 5. Right there. Negative 1, 3, I'm going to go over to the left 1, up 3. Negative 1, 3 is right there. 0, 1, 1, negative 1, and 2, negative 3. Right there. Now we need to connect our dots with a nice straight line, better than Marsh can do. Ooh, that's actually not too bad. She's kind of wobbly. So that is my function rule. Now, this is a linear function, right? Because it makes a straight line when you graph it. So this is a linear function. Let's take a look at a real world application. So I have this function rule, y equals 146c plus 30,000, and that represents the total weight of a concrete mixer truck that carries c cubic feet of concrete. If the capacity of my truck is about 200 feet cubed, what's the reasonable graph? Well, I know that the smallest amount of cubic feet I could have in there is 0, right? An empty truck. And it says my capacity, or the tip top, is 200. So I know that the numbers I'm going to have to choose is between 0 and 200, because negative 2, negative 1 isn't just going to cut it, because I can't have negative cubic feet. And I don't really want to know about only 1 cubic feet. I want to know between 0 and 200. I found that I'm going to go by 50s. Nice little jump up. So I plugged in 0, and I got 146 times 0 plus 30,000. That gave me an answer of 30,000. Plugged in 50, I got 300. 100, I got 44,600. Plugging in 150, I got 51,900. And then 200, I got 59,200. Now, let's graph those ordered pairs. Gotta kind of fill in some stuff, right? So I got cubic feet down here. And we got weight. Going this way. There we go. Let's label our axes, or let's do our scale. So I know I'm going by 50s. Let's skip one every time, so then we kind of have a little bit more room. So here's going to be 50. Actually, skip one from 0. Let's go right here for 50. Because then 0 kind of has an area for himself too. 100 would be right here, 150, and then 200. Can't go above 200 though, right? Because the capacity of my truck's only 200. Let's go up by 10,000s, and let's look. It looks like we'll skip a line each time. I think we'll be able to fit them all. So I got 10,000, 20,000, 30,000, 40,000, 50,000, 60,000, and 70,000. That's about as high as I need to get. So at 0, see, I had 30,000. So at 0, I have 30,000. Let's go and graph that ordered pair. 50 and 37, 300. So 50, 37. Well, this is 35,000, right? So I know it's going to be a little bit above that. So about right there. 100 is 44,600. So that's going to be just below the 45 mark. About right there. Oops. 150 is 51,000, so that's just going to be above the 50,000 mark. There we go. And 200 is 59,200, so very close to 60,000. Right about there. Connect my dots to the best of my ability. And it looks like I have a linear function yet again, because I'm going in a straight line. Now, what does a nonlinear function look like? There's quite a few examples of that. Same thing though, you're going to want to start with a chart. And then you're going to want to start with -2, -1, 0, 1, and 2. Those numbers. Let's plug in -2 for x. Now, do you know what these bars mean? These mean absolute value. When you have an absolute value, basically it says how far away from 0 is this number. Or, in technical terms, all you need to do is if you have a negative, it's going to become positive. If it's positive, it stays positive. So if I would plug in -2, -2, the absolute value of that is a +2. So I'm going to get 2 minus 4, which is -2. Let's try plugging in a -1. Absolute value of -1 is a +1. So I'll get 1 minus 4 is -3. Let's plug in a 0. Well, 0 is 0 from 0. So 0 would be absolute value of 0. So my answer is -4. Let's plug in a 1. So 1 is 1 away from 0, so I'm going to have a +1. 1 minus 4 is -3. Plug in 2. Absolute value of 2 is 2. -2. Isn't that kind of cool? It kind of actually makes like a little mirror effect. Let's graph and see what this graph's going to look like. -2, -2. -2, -2. -1, -3. 0, -4, 1, -3, and 2, -2. Look at that. It's actually pretty cool. It's a V. This is actually an absolute value graph. Absolute value graphs always graph a V. So if you ever see these doohickey bars here, that you're going to know you're going to get a V when you graph it. Let's do one more. So we need to graph x squared plus 1. This is going to be a different looking shape. So let's do our same numbers. -2, -1, 0, 1, and 2. Let's plug in -2. Well, I'll get -2 squared plus 1. -2 squared is a positive 4. Please put -2 in parentheses on your calculator so you get the 4. So 4 plus 1, we got 5. Plug in a -1. I'll get a positive 1 plus 1, 2. 0 squared plus 1 is just 1. 1 squared, 1 plus 1, 2. 2 squared is 4, plus 1 is 5. Let's graph this ordered pairs. -2, 5. -1, 2. 0, 1. 1, 2. And 2, 5. There we go. Notice, this is a function because it actually graphs something that passes the vertical line test. Now, if this would have been a u laying on its side, then it wouldn't have passed the vertical line test. Thus, it wouldn't have been a function. And that's the end of this video. See you later, Sabers.